All right. Page 5. I know 4 might not be quite finished, so we're going to save those for practice. And today we're going to talk about dot plots. You don't want one of those options?
There is no.
I mean, you could try and sharpen it. I don't know.
This?
Maybe.
Look at what I got. You have a truth? You need a pencil?
All right, a dot plot uses a number line to show the number of times each value in a data set occurs. So therefore, dot plots are especially useful when there are many repeated values within a set. So here's the example we're going to use to show you the dot plot. The weights of 20 puppies are given in the table below. If there's 20 puppies, I should have 20 dots on my dot plot. 1 for each of the puppies. So first, we need to label our number line for our dot plot. So look at your lowest, looks like maybe 9 is my lowest, and your highest, 16. So maybe I'm just going to start at 9 and go 10, 11, 12, 13, 14, 15, 16. So that worked out. So I'm going to go through and start putting dots on it. I'm going to cross out the data as I do so. Are you ready? 12. So I'm going to put a dot above the 12 and cross it out. 9 and another 9. Cross those 2 out. And 2 12s. So now I'm at 3 12s there. And 11. A 12. A 15, a 10. Notice when I put my first dot on, I'm trying to keep them kind of in line. That way it's easiest to compare. We have a 13. We need a 9, so that makes 3 9s. And another 12, so I'm now at 5 12s. A 13, a 15, an 11, a 10, a 12, another 10, a 16, and another 12.
Well, I think we know.
Yes, you can see your mode quite easily, right? What has the most? 12 pounds, yeah. So dot plots are also useful in showing the clusters, peaks, and gaps in a data set. So a distribution is skewed left when most of the values are on the right. So the left side is called the tail. So wherever the tail is, we call it skewed that way. So skewed to the left, which means if it's skewed right, most of the data is on the left. So the right side of the plot is now the tail. Symmetrically, a distribution is symmetric when the data on the left is approximately a mirror image on the right. So now this is like exactly a mirror image. Sometimes it would just be roughly a mirrored image. It doesn't have to be exact. Uniform means about the same in all of them. You can see that one has one more and one has one less, but it's fairly uniform. So they're approximately the same number of each data values, of each data value, I should say. A uniform distribution is also symmetric. Roly, roly, roly with a dab of ranch over there. All right. So here we're going to draw a dot plot to represent each set of data. Then we're going to describe the distribution of the data. So here are the scores. They range from 60.
There's a 55.
Oh, there's a 55 to 100. Do you think I need to count by ones? Or are they going up by fives? Fives. So if I start at 55, then 60, 65, 70, 75, 80, 85, 90, oh dear, 95, 100. I spread mine out a little too far, but that's okay. Because these number lines go infinitely in both directions, right? So now I'm just going to go through my scores and add them to my line, right? So at 65, I'm going to put a dot and I'm going to cross it out. 95, 60, 90, 85, 65, 100, 70, 90, 60, 55, 95, 90, 65, and 100. All right, looking at these, how would we describe the distribution of data? Doesn't look like it's skewed right or left. It does look pretty mirrored, so we call that symmetric. So, in other words, if I kind of picked a point and folded it over, it would look fairly similar. In fact, almost exactly similar, except there would be another one at 55. All right, number of goals scored by a hockey team in their first 20 games. So I'm going to have 20 dots to put on this plot, and they range from, I don't see any zeros, so 1 to 5. 1, 2, 3, 4, 5. So if you wanted to, you could start at 0. Remember, just because it's on your plot doesn't mean that there's necessarily data values there. So sometimes we'll see something on our plot and use that when we're finding our modes of central tendency or our range, but only if there's a dot there. All right, so here we go. 2, 4, 1, 4, 3, 2, 5, 2, 3, 3, 1, 5, 2, 3, 4, 5, 5, 2, 1, 4. So looking at this data, what would you say about it? I would say uniform for sure. All of the data values have about the same number. Of course, one has more, one has less, but it's about approximately the same. All right, high temperatures for the first 2 weeks of July. I'm going from 76, maybe? Is that my lowest? To 90. And so I don't see any odd numbers, so I'm going to count by 2s, 76, 78, 80, 82, 84, 86, 88, 90. You don't really have to keep going, but all right, 84, 76, 288, an 86, a 90, an 84, a 78, an 82, an 80, an 86, an 88, an 84, another 88, another 84, an 86, another 86, another 86, an 82, and an 80. So I would say most of my data values are on what side? The right side. So this is called skewed left. All right, yes, you may want a calculator at this point because we're going to find the mean, the median, the mode or modes, and the range of our sets now.
Oh my God. Oh my God, people.
All right, remember each one of these represents something. So this dot represents a 90. This dot, these dots represent what? What's between 90 and 92? 91. So if I were writing this out, I would say 90 plus 91 plus 91 plus 91. But you don't necessarily need to write this out if you feel comfortable being accurate. And then I'm dividing by the number of data values or the number of dots. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm dividing by 9 for my mean. Hey, diddle diddle, the median's the middle. You add and divide for the mean. So what I'm going to do, 90 plus 91 plus 91. So I got 734 divided by 9. Is that what you guys got? Oh, that can't be right. What did I do? 1, 2, 3, 4. Oh, I only put 8 points up there. 90, 3 91s. Oh, I needed one more 94. So 734 plus 94. $92. All right. Now, you can look at your ordered numbers to find your median, or you can use your dots, right? Work from the outside in. So 90 and 94, 91 and 94, 91 and 93, 91 and 92. So my middle number would be 92. Or you can use what you just wrote out. Your mode, what occurs the most? This is easy to see. 91. And your range. Hey, diddle diddle, the median's the middle. You add and divide for the mean. The mode is the one that occurs the most, and the range is the difference between. So your highest number minus your lowest. Now, I have seen people take a standardized test, and when they find the range, they say 3 minus 1. Do you see what they're doing? They're counting the most that it occurs and subtracting the least from it, of course. But you need to figure out, yes, your greatest value of 94 minus 94, which is 4. All right. Find the difference between the mean and median. So we need both the mean and median, and then we're going to find the difference. So we have to add these all up. these are going up by what? 20. This is 22. This is 26. This is 30. So if you want to write out your work, do so. I mean, a way that you could think about this, right? That might be a shortcut. 20 plus 22 plus 24. All right, 270 divided by 3, 6, 9, 10. So 27 is my mean, right? What is my median? I have an even number. So 3 and 1. Oh, my two middle numbers would be 26. So the median. So the difference is 1 page. Questions, concerns? Does that make sense?
Only were counted by 2, so now why? Oh, gotcha.
Right, histograms, otherwise known as bar graphs. It shows the frequency of data values in intervals of the same size. So these intervals have to be the same amount. So if I went from 21 to 25 and then 26 to 30, they have to be the same amount. Excuse me. All right, the height of the bar represents the frequency. Frequency means how many data values fall in that interval. A histogram does not give individual data values, therefore, it is not possible to find measures of center or the range. The histogram above shows the ages of the employees at a certain company. So we're going to use it to answer. How many employees are there total?
32.
So there are 8 in this range, right? 14 in this range. 18 in this range. There are, is that 12 in this range? There's 6 in this range and 2 in this range. So these are how many people are in each of these ranges. So we have to add them up to figure out the total number of people. So 60 employees. How many are there at most? 40. So this means at most less than or equal to 40. So here would be at most 40, right? 8 plus 14, which is what? 22. Which interval contains the most employees? 41 to 50 years. What percent of the employees are over 60? So that's these two. So 8 out of 60.
Wait, that's perfect.
What?
One below it.
Over 60. So it's these and these, right?
Oh.
Over 60. So this is 61 through 70 and 71 through 80. These are all over 60. That's why I added them together. Then I can change my fraction into a decimal because that fraction bar means what? Divide. 8 divided by 60. So 13.3 repeating percent. Remember to change my decimal to a percentage. Percent means per 100. So I'm multiplying by 100. 1, 2, 13.3 repeating percent. That is the answer to that last part, D, and number 1. All right, try number 2. How many students scored between 61 and 70? So what is this number right here? What's between? Good. How many students scored below 81? So it's these three combined, right? So 1 plus 3 plus 6, which is what? 10? Which interval contained the fewest students? That's the score. And what percent of the students scored between 71 and 100? So that's these three here, right? So now we have 6 plus 10 plus 8. Is that 22? No, 24. So 24 divided by the total number of students. There were 4 more than that, divided by 28. That's how you would get your percent of your grade too, right? What you got right divided by your total, or in this case, what we want, which is the students scoring between 71 and 100. There's 24 of them divided by 28. That gives us our decimal, and then I move it over 2 places to get the percent per 100. So 85.7%. What's the highest score on the test? We're not really sure, but the highest score someone could have had was 100. Because just because they're in this range doesn't mean anyone scored 100, right? It means that they could have all scored between 91 and 100, I guess.
They all could have scored just that.
Yeah, exactly. All right, we got a little bit more practice. Yeah. Here.
What?
Is this page 8 for you? All right, how many students weigh between 7 and 7.9 pounds? So we're looking in this space. How many? 9. This is their birth weight.
Google's are asking people about their birth weight.
How many students weighed less than 8 pounds? So that would be all 3 of these combined, right? So 9 plus 3 is 12, plus 1 is 13. Which interval contained the most students? All right, typing speeds of students in a keyboarding class is given below. What percent of the students typed between 41 and 45? So we need to know the total, and we need to know the number between 41 and 45. So how many between 41 and 45? Looks like 9 divided by our total, which is 3. Plus that 9 is 12, plus 5 is 17, plus 2 is 19, plus 1 more is 20. Percent means per 100. So if I multiplied the 20 by 5, I would get 500. So here I have 45 per 100, which is 45%. Good review for you 8th graders who haven't worked with percents, fractions, decimals, all that, right? In a while. So that's how I would find the percent, or you can change it to a decimal. 9 divided by 20 would give you 0.45, 45 hundredths. You would move your decimal over 2 places. That was really random, but okay. The histogram below shows the test scores on a science test by a group of students. What percent of the students scored between 91 and 100? So how many scored between 91 and 100? 24 divided by the total. So this is 24, this is 30, this looks like 20, 12, 6, and these are going up by what, 3s? So I would make this a 30 with this, so 60, 80, 92, 95. Is that what you guys are getting?
Yeah.
So then I would say 24 divided by 95. Well, if I was rounding to the 10th, I would go up because my next number is a 6. So it makes sense that it's about a quarter because it's a little less than 100, yes. Oh, you're right. This should be 21. Did I screw up all my other numbers too? Just this one? So that makes it out of 96. So that makes it kind of nice. Yeah. We lose 0.3%. All right. The histogram below shows the number of raffle tickets sold by a group of students. What percent of the students sold at most? So that means less than or equal to 15. So from here, this way. So here, there are 2 sold, plus 20, plus 14. So 36. 36 out of the total. So to 36, I'm going to add 6, which is 42, plus 8, which is 50. Here's a good review. 50 goes into 100 easily. So I would multiply it by what to make 100? 2. Whatever I do to the top, I have to do, I'm sorry, the bottom I have to do to the top. So 72 per 100 is the same as 72%. That's not so bad, right? All right, you've got about 10 minutes. So I want you to be sure you're reviewing and going back to pages 3 and 4 and finishing those up. Tomorrow, you will have a sub. So you are going to be doing pages 9 through 11, I believe. So pages 9 through 11 tomorrow.